In today's video, we're going to go over the different methods for factoring and also deciphering when you use which method. So I'm just going to go through a mix of problems and we're just going to go through them step by step to try to understand when you would use which approach. So this right here is called a trinomial, or it's otherwise known as a quadratic. The way you know that something is of this form is that you look for an x squared term. That's what makes it a quadratic. And then typically you have a term that just has an x with it, and then you just have a single number. And the exponents would be x to the second, x to the first, and this is technically x to the 0. Now, you guys are pretty familiar with these. The way you factor these are that it has to multiply to this number, but add to this number. And what we typically do is we just try to go through some factors. So for 5, there's not a lot. So I know 5 times 1 is 5. But what you want to know is you don't want to get 5, you want to get negative 5. Now in order to multiply and get a negative number, one of your numbers must be negative. So it's either a negative 5 times 1 or a 5 times negative 1. Either of these will give you the negative 5, so we don't need to check those. But what we need to make sure is that it will actually add to 4. So I'm going to test negative 5 plus 1 and 5 plus negative 1. Negative 5 plus 1 is going to be negative 4, because when your larger number is negative, your overall answer is negative. 5 plus negative 1 will be 4 because the larger number is positive. Now since this adds to 4 and multiplies to negative 5, these would be our factors. So it's going to be x plus 5 and x minus 1. In this problem, we once again have a quadratic, but what's different this time is that there's a coefficient in front of the x squared. You have a number in front. So the first thing you always want to check if you have a number in front is see if there is a GCF to factor. A GCF is a greatest common factor. It's a number that's divisible by all the terms. So ideally we want this question to go back to looking like this question. We want just an x squared. So what we need to ask ourselves is, can we pull the 2 out from each of those terms? And the answer is yes, because 12 can be divided by 2, 18 can be divided by 2, and of course 2 can be divided by 2. So I'm going to pull out the 2. 2 times x squared will be 2x squared. 2 times 6x will give us the 12x. And 2 times 9 will give us the 18. So now, this looks like a problem that we're used to if we just ignore the 2 in front. And we can factor this just like before. So I want to think of a number that's going to multiply to 9, but add to 6. This one's going to be a lot easier because we're multiplying to a positive and we're adding to a positive. So we don't have to really worry about the signs in this case. Now, 9 and 1 multiply to 9, and 3 and 3. We can tell right off the bat 9 plus 1 isn't going to make 6, so our factors are 3 and 3. So we're going to have x plus 3 and x plus 3. And it's a little awkward to have x plus 3 written twice. So a way that we can clean this up is just have x plus 3 squared. This one looks different than before, primarily because we have a cubed. So don't be alarmed because it's a cubed. The first thing you want to see is, can you pull out something from every single term? Is there a common factor? And the common factor is going to be a. Since this is a cubed, this is really a times a times a, 3 times. Since this is a squared, it's really negative 5 times a times a. And this is 4 times a. So it's clear from each of these that you can take at least one a out. So that's exactly what I'm going to do. I'm going to factor out an a. If I take one a out of here, I have 2 a's left. So this is going to be a squared. Because when you multiply, your exponents get added. And this has an imaginary a to the first. If I pull out 1a here, I'm left with negative 5a over there. And if I pull out the a here, I'm just left with 4. Once again, this looks like a quadratic that we're used to. we can go through the same method that we've been doing. So I want it to multiply to this number, and I want my factors to add to this number. This time you want to multiply and get a positive. The ways that you can multiply and get a positive number are by having both of your factors be positive or by having both of your factors be negative. So I can just look at some. I could have 4 times 1. I could have 2 times 2. But I could also have each of these factors be negative. Since I wanted to add to a negative number, I want my factors to both be negative this time. Because having them both positive, there's no way it's going to add to a negative. And negative 4 plus negative 1 will add to a negative 5. So this is going to be the factors I'm going to choose. So this time A will be on the outside. I'm going to have A minus 4 and A minus 1. Now making this a little bit more complicated. So this is going back to what we've had with the trinomials. However, we have a number out in front. But the problem this time is that you can't pull out the 3. Because if you take 17 and you divide it by 3, it won't go in evenly. So now we need a different method for factoring. This is what is known as the A times C method. So for this method, the number in front of the b squared or x squared term is always known as A. The number in front of your single variable is always known as B. And just the lone number is always known as your C term. The way you kind of approach these factoring problems is that you multiply A times C. So 3 times 20 is 60. Now I'm going to go through a similar process. I'm going to see what multiplies to 60 but adds to 17. So I'm still doing something very similar to before. So let's think about numbers with 60. 60 is even. I could divide it by 2. 2 and 30. Since it's adding to a positive and multiplying to a positive, both of my factors are going to be positive. 2 and 30 is not going to add to 17, so that factors out. Let's just go slightly up. If I take 60 and I divide it by 3, that would be 3 and 20 like we have. 3 and 20 could get me 17 if it was 20 minus 3. However, I don't want a negative because then it's going to multiply to a negative 20. So I'm going to just keep going. 60 divided by 4, 4 and 15. That's not going to get me 17. I'm going to keep going. 60 divided by 5, 5 and 12. This one's going to work because 5 plus 12 is 17. Now the way we go about this is I'm going to write these terms within this question. So the way that this is going to work is I'm going to write 5 and 12 in place for the 17b. So I'm going to have 3b squared plus 5b plus 12b plus 20. So I'm going to just go in, and instead of writing 17b, I'm rewriting it as a sum of two numbers that would add to 17. And what you want to do now is factor by grouping. So you want to take groups of 2, and you want to pull out what's in common. All right, so why don't we factor out the b in this case? Then I'd be left with 3b plus 5, because b is in common to both. Now over here, what goes into both 12 and 20? You want to think of your greatest common factor. I'm going to pull out a 4. It's going to be 3b plus 5. Now the way this works is if you did it properly, your factor by grouping, this should be repeated. And then I'm going to pull this out because the 3b plus 5 is in both. And then I'm going to write out what's left, which is the b plus 4. If you factored correctly when you do factor by grouping, you should have your terms in parentheses repeated. If the terms in parentheses are not repeated, you did something wrong.